Good morning, ladies and gentlemen. I hope we had a lovely weekend. So, a brief overview of what we've been doing. Um, we started with entities, and our entities contained our objects, our entities, our value objects, and aggregate fruits. And then we have factories for instantiating our value objects and entities and aggregate fruits. Then we have repositories for doing the basic create, read, update, and delete. That's data manipulation on our entities and value objects. Then we have services that exposes the repositories and also contains business logic. And that's where we stopped last week. And we implemented one called RAISE service implementation. And also singleton, like we talked about last week. So now, the aim of this is to build this application in such a way that we expose microservices. And these services are sometimes called endpoints and should be stateless. And we already implemented a service layer. However, we've not exposed any endpoint to that service yet. So how do we do that? I think we should start with some background knowledge on microservices. Okay, let us look at this tool with the hope that you all can see my screen and can also hear me. So according to microservices.io, it says microservices, also known as microservice architecture, is an architectural style that structures an application as a collection of services that are highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, owned by a small team. Microservice architecture enables the rapid, frequent, and reliable delivery of large, complex applications. It also enables an organization to evolve its technology stack. So the pattern language is your guide. It says the microarchitecture is not a silver bullet. It has several drawbacks. Moreover, when using this architecture, there are numerous issues that you must address. The microservice architecture pattern language is a collection of patterns for applying microservice architecture. It has two goals. Pattern language that enables you decide whether microservices are a good fit for your application, and the pattern language enables you to use microservice architecture successfully. So a good starting point is the monolithic architecture pattern, which is a traditional architectural style that is still a good choice for many applications. It does, however, have numerous limitations and issues, and so a better choice for a large complex application is microservice architecture pattern. Okay, so what this is saying is that microservices or microservice architecture enables you to structure a very large application into a collection of services. And these services are not tightly coupled. They can stand alone, and you can independently deploy them. and they can also be maintainable and testable, as compared to the monolithic architectural style that we all have been doing. So you have an application and you have a very big application and you design one big solution and everything is tightly coupled. That's monolithic architectural pattern. So if you read about all this pattern stuff, you would understand better why microservice architecture should be used and when you should use it. An example is this. This is a microservice architecture. It's got so many things that can be independently deployed. But we're assuming that we understand what we understand that we need to do a microservice in this case, a microservice design pattern in this case, or architectural structure in this case. But for future read, you can read this to understand microservices and when you use them and how to use them and how it functions. Now there are different levels of microservices. If we look at our code is monolithic in the sense that we have one application called TP payroll that has all the stuff in it. It can also be seen as a microservice application because we already have a service layer that is obviously going to implement all the services independently for our entities and expose them. So it's got microservice and is also a monolithic application because you can also break down this application into very many applications, and that's the highest level of microservice. When you break down one application into different applications that can stand alone and be independently deployed. For example, you have one application that talks about demography and demography alone. So it may be called T payroll demography, and it has only demography and factories for demography and repositories for demography and service for demography. And then you have another application for user called TP payroll user, a separate application on a separate IDE window that will have the entities for this and also a factories for the user and repository for the user and service for the user. That's the highest level of microservices. Now, each of these applications can be independently deployed. But in order not to overwhelm you for a start, we have it in this structure. So this structure is kind of monolithic because you have everything inside this and it's in one application. But it also implements a form of microservices in that you have a service layer and you're going to implement all the services of your entities and value objects in there, and they can be exposed as different endpoints. So that's for microservices. Now let's look at exposing. I think this is saying the same thing. In the meantime, do you have any questions? Okay, so now we understand what microservices are. So how do we expose microservice? Okay, I'm just going to go ahead and tell you. I was looking for a resource on the internet. Maybe I'll find that later, but I'm just going to tell you. So there are two basic ways of exposing microservices, or two basic common architecture for accessing and exposing microservices. So one is SOAP. I don't know if you guys have heard it. It's sometimes called SOAP. I don't know if you've heard of it. Not the soap for washing. Um, the reason I'm doing a quick search right in front of you guys is to show you that you can actually do this on the internet and get the information that you need. So SOAP. And my internet is quite slow. Bear with me. According to Wikipedia, it says SOAP, abbreviation for Simple Object Access Protocol, is a messaging protocol specification for exchanging structured information in the implementation of web services in computer network. Now let's take a step back. We are designing this and we want to expose endpoints. What's the reason for exposing endpoints? We want people to be able to access our application, and it's usually over the internet. So this is a web-enabled application. Now, what I said is not, I didn't say this is a website or a HTML application. It's a web-enabled application. It's an application that can be hosted somewhere and exposed, and people can connect via the internet to access that application. So it's a web-enabled application that is exposed on the internet. So that communication between your client and your application happens in the internet. So that's why we need to, we use the word expose and also endpoint. We're trying to expose an endpoint, and the endpoint is usually the address of a functionality in the application or the application itself. So that address on the internet is what you're trying to expose for people to be able to access and communicate with it. And by communication, they have to send a request to that address, and then your application will also always listen and wait for requests coming on a particular address, and then it takes it, performs computation on it, and sends back a response to whoever the client was. So that's the communication. So let's go back again to this. It says SOAP, abbreviation of Simple Object Access Protocol. It's a messaging protocol specification for exchanging structured information in the implementation of web services in computer network. So this is one way to answer this question. How do you expose microservices? Now, microservices, yeah, you can also be seen as a web service. or it's microservice, a higher form of web service. So you can also read on web services to see. According to this guy, this is tutorials point. The internet is quite slow today. Can you actually see, can you all see my screen? And can you hear me perfectly? So I'm wondering why this is. Aha, beautiful. Let's see if we can get another one. According to Wikipedia tutorials point, it says web services are open standard based web applications that interact with other web applications for the purpose of exchanging data. Web services can convert your existing applications into web applications, web-enabled applications, not websites. So this is a brief definition of web service, which may work hand in hand with microservices. But I think microservices is a further step to web services. But a web service means that you are uh, trying to make an application into a web-based application that uses a standard to exchange data. Okay, so to expose your web service, you need SOAP. SOAP is one of the ways of doing that, and SOAP stands for Simple Object Access Protocol. And it uses a specification to exchange structured information. So for SOAP, it uses XML. If you remember one of those days when we used to meet in class and I told you there are two ways of communicating over the internet, because the internet is open for all, so you have to standardize communication against client and server. If you don't do that, then people will not understand themselves in the internet. So the two ways for standard exchange of information on the internet is XML and JSON. XML stands for Extensible Markup Language, and it has tags. These are just the basic background that I'm giving you. XML website. Extensible Markup Language is a markup language that defines a set of rules for encoding documents in a form that is both human readable and machine readable, and is also used to transfer information over the internet. An example of an XML is this, and you're already familiar with it because we have a POM file that is an XML. This is XML. That's why you can deploy this on any server and it's going to recognize what you're talking about, because this has already been defined somewhere. So your XML has nodes or attributes. So in this case, this is the parent attribute with all this child to, from, heading, and body, and then a closing tag. And then this is an attribute with a value, attribute, value, attribute, value, and so on. So this is human readable, sort of, and also machine readable. So one of the standard way for using SOAP as your messaging protocol is that your Message has to be structured in XML. If you read
Um, Good morning, everyone. Sorry for that problem. Yeah, the lecture is coming back. I need to be patient a little bit. I think it is network problem. Yeah, it should be network problem.
my internet is crappy, so I apologize for that. So sometimes I'm going to get disconnected, but I'll reconnect again and continue from where I stopped. So I was talking about using XML to communicate. So SOAP is one way. Now the other way is let me just close all this. The other way is REST. So REST is also an acronym and it stands for Representational State Transfer. It's an architectural style for distributed hypermedia system. And then it gives us the history. It says like any architectural style, REST also does have its own 6 guiding constraints, which must be satisfied if an interface needs to be RESTful. So an interface that implements the REST, what did I just do? Um, an interface that implements the REST architecture is usually called RESTful. And the guiding principles for those are client-server, stateless, cacheable, uniform interface, layered system, code on demand, optional. Um, these are just basic things you need to know about REST. So there are two ways, there are two major ways for exposing or accessing a microservice or a web service over the internet. One is the SOAP and the other is REST. Now, since we say that we're implementing domain-driven design and it says that our service layer should be stateless, then we'll see that stateless is one of the guidelines of RESTful or REST architectural pattern. So we are going to be exposing or implementing the REST architectural style on our application. Now, there are protocols that you need to understand in order to expose whether it's a SOAP web service or a REST web service. And that protocol is called HTTP or HTTPS. Now, S is over a secure channel. So HTTP is Hypertext Transfer Protocol. It's an application layer protocol for transmitting hypermedia documents, such as HTML. So now, this is a protocol that enables you to actually communicate whatever you need to communicate in whatever form. Whatever form I mean, whether SOAP or REST. And there are different methods in this protocol that you might be aware of now. So there's the GET. There are actually, how many of them? I think there are 7 of them, or 8. A quick search, HTTP methods. Yeah, let's do this. And my beautiful internet is slow. Okay, so this is here. It says this is according to REST API tutorial.com. Using HTTP method for RESTful service. So it gives us a summary of the methods that you use in the HTTP protocol. So there's the post, get, put, patch, delete. And this is not entirely all, but it maps them according to the CRUD that we already have. So post is to create something, get is to read, put is to update or replace, which is update. Patch is to update or modify, delete is to delete. This also has get. This is by Oracle. I don't know what here. It has get, put, delete, post, head. And it's telling you that head method is similar to the get method, except the message body is not returned in the rest. So as usual, before, okay, I think this is 2010. As usual, before you do stuff, you need to find out the particular method in the protocol that suits your need. I hope we're following. So try and read on this. There is post, get, put, patch, delete, and there's also head that is equivalent to get, but the difference is yeah, this is a better one, or some, yeah, this is a better stuff. And it also explains it. It says get requests are the most common and widely used among used methods in APIs and websites. It has post also, it has put, it has patch, it has delete, it has head, is identical to get except without the response body. It also has option. Option requests are one of my favorites, though not widely used as the other this. In a nutshell, an option request should return data describing whether other methods and operations the server supports at a given URL. So the ones I'm basically interested in get post put head delete patch. Option, yeah, you can read about that. But these are the methods that are supported in the HTTP protocol. I hope that is clear. So we have now established that we're going to be using REST, and we're going to be transmitting data over the HTTP protocol. And for REST, the standard of data transmission is usually JSON. JSON is a JavaScript object notation, a lightweight data interchange format. It is easy for humans to read and write. It's also easy for machines to parse and generate. So we have established that we're going to be exposing RESTful web services, and we're going to be doing that over the HTTP protocol, and our data format is JSON. So let's practically implement that. So to implement that, we now need to go on. Is either you do that yourself, or we learn a particular framework. Let me close this and start afresh. We will be using the Spring Boot we will be using the Spring Boot framework, which is under the Spring framework, to expose our web services. So it says Spring Boot makes it easy to create standalone production-grade Spring-based application that you can just run. So I'd like you guys to read around Spring Boot. I think there's a documentation which I'm trying to find now, so that we can go through that and use it. This is one, but I need the documentation. I think that's it. So we'll be using this stuff. This is a reference guide for Spring Boot. You can actually download it, or you can go through the internet and see what it's talking about. So let's just jump to getting started. Which is a lot of text to read. So please go through this stuff to understand it. After I've given you an example, and then maybe you understand it while you're going through it. So Spring Boot can be used in different environments, but we're using it in we're using it for a particular build tool, Maven build tool. It can also be used in Gradle. It's got a command line interface, which is CLI, and so on and so forth. So let's see, using Spring Boot. So it says here, on this item number 3, using Spring Boot, it talks about how to use Spring Boot in different build system, and how to run your application, and how to do auto configuration, and the best practices on Spring Boot. It always recommends using this. Let's see if we can go there. Why is it getting started? Introduction. Yeah, I cannot. It says if you're getting started with Spring Boot or Spring in general, start by reading this section. It answers the basic what, how, and why question. It includes an introduction to Spring Boot along with installation instructions. We then walk you through building your first Spring Boot application, discussing some core principles as we go. So it says Spring Boot helps you create standalone production-grade Spring-based application that you can run. We can take an opinionated view of Spring platform and third-party libraries so that you can get started with minimum fuss. Most Spring Boot applications need very little Spring configuration. So Spring is the main framework and Spring Boot is just a child framework. You can use Spring Boot to create Java applications that can be started using the that command or more traditional word deployment. We also provide a command line tool that runs Spring script. So it gives you system requirements. You need to have Maven, and then also supports the following servlet container, Storm Jetty, and that. So installing Spring Boot, we are just going to include it. We're not going to install it on our computer. We're going to include it on our configuration file because we're using Maven. Where did it say? Yeah, not this. This. So it says we need to start by creating a Maven POM file. The POM file is the recipe that is used to build your project. So open your blah, blah, blah. We already have this. So it says we need to add this thing here in our application to make it a Spring Boot application. So let's go to, how do I divide my screen so that you see? Okay. So it says we should open our POM file and add, where did it go? Terrible. This is one of the drawbacks of showing things over the internet. Now I have a small screen and you are not going to see what I'm doing. I think that's it. So it says we need to add this. Now you look at the position. The position of this is an XML file, and XML files needs to be in a particular structured order. So there are tags, and the tags mean something. So we'll look at this. It looks similar to ours, and we see that there is a bunch of things that we don't have. this, but that's not what we're looking at now, because the POM file, if you remember, we generated ours using the quick start. And a POM file can contain different things, but what we're interested in is the Maven part of it. So we need a parent tag, and this parent tag is just on the root of the project file, project tag, not inside any other tag, but on the root of the tag. You can add it anywhere. So you can see this parent is not inside version or inside model or inside group. It's standing alone directly on the root of that. So you can add yours anywhere you feel comfortable. You can add it. So let's start with parent, and your IDE should complete that to you. So then we start with group ID. You type org, your IDE should give it to you, and then you be sure that you're adding the parent, not the web. This has to be parent. And it needs a version. You can do an alternate enter, or space, control space, control space. Show you what your ID already has, and I have 2.3.2, or you can actually copy what they have, 2.3.3 release, and hopefully it should download that for you. So let's see. One way to see that this thing works is you would have to go to the where's that? I think it's here, Maven, and then you do reload all Maven projects. So this goes through your POM file and downloads a thing that you don't have already, so that you don't see the red mark under there. So that's done. So this project is on its way to becoming a Spring Boot application. So let's keep going down. So now it says the Maven dependency tree command prints. Okay, you can see that the Spring Boot startup parent provides no dependencies by itself. One way to see that is when you go to your project and you check the external libraries. You can see what I have here. Nothing. This is just what we have got sent. We've got JUnit and this stuff. So there are no dependencies added yet. So it says to add the necessary dependencies, edit your POM file and add the Spring Boot starter web dependency immediately below the parent section. So it says we should add dependencies. So let's go there. We already have a dependencies tag, so we don't create another one. Important. Then we just need to add a dependency. Let's just go and add dependency. And the artifact ID, let's call it, it's Spring Boot Starter Web. And the org ID is, the group ID is same org.springboot, spring framework.boot. So let's go and look at our project again, or we can see this. You can start downloading dependencies that I've added. And this should contain, you can see that things are happening here. It's adding all the dependencies that we need. So now it has given us all the things we need to make sure that our application uses Spring Boot. Now you'll be wondering what Spring Boot Starter Web is and Spring Boot Starter Parent is. It's defined somewhere here. That's why I'll need you guys to go through this after I'm done with this class. It's defined somewhere here. I think in one of those, was it here? Here it says our application for smoke test uses Spring Boot starter test and a Spring Boot starter parent in the parent section of the POM. So the Spring Boot starter parent is a special starter that provides useful Maven defaults. It also provides a dependency management section so that you can omit version tags for blessed dependencies. Then it also tells you here that, okay, it didn't actually define this here. But if you go down to, I think I showed it now, I can't remember where I saw that. Here, you'd see the name and the description. So I think the data parent should be here, Spring Boot starter. It's not there. Okay, I think it's defined here. Starters are a set of convenient dependency descriptors that you can include in your application. You get a one-stop shop for all the Spring and related technologies that you need without having to hunt through sample codes and copy and paste loads of dependency descriptors. For example, if you want to get started using Spring and JPA for data access, include the Spring Boot Starter Data JPA dependency to your project. So what this starter, let me just go describe that here. What this does is that it gives you all the data dependencies that are web enabled, because we're trying to expose services over the internet. Then it gives us all the dependencies that are web enabled. However, you need to declare this parent so that every other thing can use it. And when you declare the parent with a version, you now don't need to include versions of your child Spring Boot artifact IDs. So this has given us all the things we need to make our application a Spring Boot application. As you can see, if you open your extended libraries, you'll see they contain a bunch of Spring Boot stuff now. Okay, so the next step will be how to run it. So after that, after we've done this, writing the code. To finish our application, we need to create a single Java file. By default, Maven compiles sources from source main Java. So you need to create that directory structure and then add a file named to contain the following code. So what it's telling us is that by default, close this, by default, Maven looks at source, main, and Java to start compiling. And since we started, this is a Maven project, and we started using the quick start, it has given us that project structure, so you don't need to bother recreating it. There's source, main, and there's Java. So it says here that we need to create something on the root of that application to contain the following code. Now, where's the root of our application? The root of our application is not Java. It has been repackaged into com.statup. So the root of your application is com.statup because it's directly under Java. So you need to create a file, a Java file here, and it needs to have a descriptive name which corresponds to your application. So my application is a payroll, so I can say payroll application. You can give this any name if you want to be creative. Yeah, but let's just give it payroll application, and it's a class. So you'd see that it doesn't belong to any of this package. It's standing on its own directly on the root of the application. Very important. So it says we should put in this code. So it has this address configuration. Okay, let's just go through this before I start writing on the code. It has REST configuration, and we see that it also has at enable auto configuration. So these are injections. So REST controller and at enable auto configuration is directly on the class. It says although there's not much code here, quite a lot is going on. It says the REST controller and the request mapping annotation. Okay, let me go there. So this mapping annotation is on a method called home that returns a string. And there's a public static void main that has this content, Spring application.run, and it passes the class main.class and arguments that you're getting from the public static void main. So it says our first example is annotated with REST controller. Is a stereotype annotation. It provides hints for people reading the code and for Spring that the class specifies that the class plays a specific role. In this case, our class is a web controller. So Spring considers it when handling incoming web requests. Very important. So if you want your application or your class to be a controller, what kind of controller? It's a REST controller. That means it's exposing a web controller. So Spring considers that class and knows that this class is going to be waiting for a request and might return a response. And the request is coming over the internet, a web controller. The request mapping annotation provides routing information. It tells Springs that any HTTP request with the path should be mapped to the home method. So this says request mapping provides routing information, and this is the path. So when you do your www.something/, it comes to this. Spring maps that request to this, and then it returns that. Then the enable auto configuration is a second level annotation. This annotation tells Spring Boot to guess how you want to configure Spring based on the jar dependencies that you've added. Since Spring Boot Starter Web added Tomcat and Spring MVC, the auto configuration assumes that you are developing a web application and sets up Spring accordingly. Then it says the main method. The final part of the application is the main method, is a standard method that follows the Java convention for an application entry point. You do know that the entry point for any Java application, any Java standalone application, is the public static void main. Our main method delegates to Spring Boot Spring application. That means it calls Spring Boot application, as you can see here. Spring Boot Spring application. By calling the run method. Spring Boot application bootstrap our application starting Spring, which in turn starts the auto-configured Tomcat web server. We need to pass example.class as an argument to the run method to tell Spring application, which is the primary Spring component. The argument array is also passed through to expose any command line argument. So let's go and do that on our stuff. So we have public static void main, and this called Spring application run, and it takes payroll application.class and args. You won't be able to use this if you have not added, first of all, this dependency and that dependency, this parent and that dependency. You won't be able to use that. So let's close this. Then it says, you can see there's a start stuff, a run sign here. You can run this, but let's run it and see what happens. I'm going to take you through a series of errors in the hope that you understand what's happening. So we're running this, and let's see. You can see it started. It started Spring Boot, and it says started this on that with PID. It says no active profile. It now says unable to start web server. It gave a lot of stuff here. So why is that happening? Because we've not followed every convention that we needed. It's unable to start a web server because we have not named a single class as a controller. So if we name this a REST controller, let's see again. Let's run that. Still, it's still unable to start the web server. So let's do everything that they want us to do. At enable auto configuration, you can see that all these things are coming from the Spring Boot package framework. And then let's give it a request mapping. Okay, let's run this. You can see as soon as I added the enable auto configuration, this sign came up. Let me take it off. You can see that. And I add it, and that comes up. And when you mouse over that, it should tell you something. Okay, so let's run this again. You can see that it's now starting. You can see it's starting the server, the service with Tomcat, starting that, and it tells you that your Tomcat server, which is included in the Spring Boot application, has been started on port 8080, and it finally tells you that your application is up. It started it in 4 seconds, so the application is up. So if you go to localhost, because this is a localhost 8080. Oh, what's happening? Now let's go check. It says, you see, initializing that and that and that. Now, when you read this error, Spring Boot gives you a kind of default error page called white label error page. It tells you this application has no explicit mapping for that. So you are seeing this as a feedback. It has no explicit mapping for this address. So we go to add mapping. We just say, let's add string home, return payroll application demo. So we need to map this to that URL and say request mapping, and the path is that. So let's run this again. So now I need to stop, or you restart. You can either stop and start it, or you restart. And the application is started. And you can see that it has mapped something here. So let's go back there and see if the error is still there. No, the error is no longer there. So you see it responded with whatever that's inside that method. It responded with payroll application demo because Spring Boot took this part and mapped it to this method. And since this is a REST controller, it looked at this and it enabled the auto configuration to be a web application since we added a web starter. And then you'd do a request mapping at home, and then you have your application running. So this application is running, and that endpoint is running. And this is a Spring enabled web service. You can see you've exposed just blah. And I think there's a way to expose multiple stuff, if I can remember. Home. Is it like this? I don't think so. Okay, I think it's like this. So you have to restart this again. Stop and start. Now we already 1 minute. I think I have to stop here. Do you have any questions to ask? So if I run this, it gives me that. If I also put home, it also gives me that. So this is a way to map multiple URLs to the same thing. So this can be index.xyz. You can see the power of, I need to restart this again. And let's see if that works. Tells you there's no mapping like that. So let's do index.xyz. It tells you, yeah, it's there. You can also do with nothing, and it's there. So this is an introduction to a controller. So you see the title for this particular session was using DDD Part 7 controllers. So this is a controller. What a controller does is it exposes a website, an address with the URL and maps it to your methods. So that means we need to expose controllers for all this and have URLs mapping to all of this, which will continue in our next session. So you don't have any deliverables for now. Your deliverables is to please go and read on all these things that I've talked about: microservices, web services, Spring Boot documentation. Just read the basics for this. Getting started, just try to follow it, and then get familiarized with HTTP methods, so that next week we can continue. But do you have a question with this? Do you have any question on how to make your application Spring Boot enabled? Yes, Mr. Golden.
Hi, sir.
Yeah.
I wanted to ask: is it a must for us to use the Spring Boot wireframe framework, the Spring Boot framework? What if I use maybe some other framework like Apache Spark in our project?
Yeah, for the purpose of this course, it is a must that you use Spring Boot because we're trying to teach Spring
Okay.
Boot. But in real life, you have very many opportunities to use whatever you want to use, provided you understand what that framework is talking about. Now, one of the reasons for using Spring Boot is that they have perfected the idea of injection. If you remember me saying this in class, they have
Yeah.
perfected the idea of injection. So they are very good at injecting things. For example, to make this class a controller, you just annotate the class with rest in controller, and it knows that this class is a controller that is based on the web. But if you have any other thing that you want to use, not for the purpose of this course, but in real life, yeah, you can. You feel free to use that.
Okay. Okay.
Any other question? So in our next class next week, we'll be talking about. In the meantime, do we have any free time this week? I don't know if I have a free time on Thursday, because we need to round up some stuff so that we can concentrate on your marks. When I need to round up everything so that you're done with your project, and then we now revisit all your marks for those of you worried about your marks. So I would need, one of these days, I would need to fix a class to continue with our lecture, because once a week may not seem realistic. However, if we don't have time this week, maybe we'll continue next week Monday, and I'll continue with controllers on uh, on your services, and then you'll be given a deliverable. So now you have 1 week without any deliverable, just to go and familiarize yourself with this, learn the basics of this, which is microservice, know the difference between a microservice and a monolithic application, then know the difference between SOAP and REST, and then know why you're using REST, and then know the protocols, the HTTP protocol, and the methods for the HTTP. And then in Spring Boot, know that you need to add the parent in your POM file and a dependency for the starter web, and why you adding starter web. You need to know that. So just read around that, and then use my application as a reference on how to make your application a Spring Boot application. Then we'll continue from there next week. Questions, comments? Any questions or comments? Okay, in the absence of none, thank you for your time and enjoy the rest of your day.